and
Recording is on.
uh, and like I was working there for like last 1.5 year. Yeah, that's pretty much about it. I don't have a expertise in
Recording is on.
I don't have an expertise in system design, so like this is the first time I'm going through it. uh,
Okay. I think then we started at the correct time. I mean, we'll be starting from the basics, so I think that will be helpful to you as well.
yeah.
Yeah. Shivam.
Yeah, I'm Shivam Garg. Currently, I'm working in the TCS as a chatbot developer. In there, we use the Node.js uh, with some framework, conversation framework. So, that's, I'm working as a backend developer in there. Uh, and I have 1 and 2 month experience in there. And I also just currently I'm starting to learn some system designing part. So that's my also I'm also as a just like a beginner also. So that
Yeah, that's nice. Sounds good. I am Mohammed, and I basically work as a senior software engineer at Soroco, India. And I basically I'm quite good with high level design, but low level design is something that bothers me sometimes. That's why we all are over here. And yeah, so I think we can start. I'll switch off my video and I'll try sharing my screen, and I'll just uh, we'll just refer the document that I had prepared, and I'd also shared that in the group. Yeah, so just let me share that. Where do we have the share screen? Yeah, just let me know if my screen is visible.
Yep. Yeah.
Okay. Yeah. So starting with basics of low level design. So basically, I mean, companies usually conduct these the system design rounds, basically for checking what all is if the candidate is able to build systems or not, build complex systems or not. And basically you will be given before that, the basically system design will be, there'll be two kinds of divisions, two kinds of questions that can be asked. One will be like a high level design, where the architectural details and how to scale your system, it will concern around that. And the other part will be like designing object oriented systems, that we know it better as low level design. So the main objectives around this low level design is like, you'll be given a problem statement. For example, designing a LRU cache, or designing a Dropbox kind of system. Any kind of generic problem statement you'll be given, and you'll have to basically come up with a solution using your object oriented designing skill. And so basically, let's say you have a question like designing a Dropbox kind of system. So a Dropbox system in itself, I mean, it's a huge system. I mean, and I think you'll in the during the interview you'll get a timeline of around 1 hour to 1.5 hour at max. And in 1 hour, obviously, you cannot design everything around Dropbox. So what you'll do is you'll basically write down the main features, all the very key features. You'll jot them down, and you'll basically design your system around that only. So and basically the interviewer will check you like, how much you're comfortable with the OOPS concept. And if you are using any design patterns, or any design concepts, any design principles, so those stuffs. Yeah. So the prerequisite for such kind of questions, such kind of problems will be like any programming languages you'll have to be good in. You can use any programming languages like C++, Java, Python. I prefer Java mostly. and apart from that, you'll have to have good command over OOPS concept. I mean the basics of OOPS concept, like abstraction, encapsulation, these stuffs, and along with that, I mean association and aggregation, composition, these stuffs. Along with that, you'll also be required to have a good idea about design principles like solid. I mean, I've seen that. I mean, from whatever interviews I had given for system design, I'd seen that they usually ask questions around, I mean, a few principles around solid, and they just check, I mean, if you are clear with those principles or not. And along with that, you'll have to have a good idea about design patterns. So design patterns, basically, I mean, there are three different kinds of design patterns. One is the creational, one is the structural, and the third one is the behavioral. So, like based on all the three different kinds, I mean, there are different. I mean, around there are around 15 to 20 total design patterns. I mean, you don't need to learn all of them. I mean, there are few of the very famous and very frequently used design patterns. We'll just go through all those maybe in our next session tomorrow. Today we'll just go around the OOPS concept, and we'll just go around the design principles. Yeah. So any questions? Anyone? Anything anyone would like to add over here?
Yep. So we'll
Yeah.
be dividing this into two subparts, right? One will be just the low level design where we'll talk about oops and everything, and the other is high level design where we talk about distributed systems and so on, right? Like two different tracks, I guess.
Yeah. Correct. Correct.
And when you talk about low level design, so just like method stubs, or we are talking about actually coding it out?
I'm sorry, I was on mute. Yeah, so I mean, by low level design, what I mean is, I mean, what I plan is, I mean, obviously, everyone over here can add on to that. So I was
Mhm.
thinking, like, I mean, first we'll go through these basic stuffs. Like, I mean, since we saw that, I think Jatin also and Shiva also. I mean, they are not very much. I mean, they said that like they're just beginners over here. So we'll, I mean, just for the sake of, I mean, complete. I know that, I mean, the basics of OOP concepts, I mean, most of us would be knowing. I mean, if not, I mean, we'll just go through them just for the sake of it. And along with that, we'll just cover a few design patterns. I mean, that was what I had thought. After that, what we'll do is like every weekend, what we'll do is like we'll take one problem. Let's say, for example, designing Twitter feed. I mean, that will be one
Mhm.
problem. And based on all the, I mean, and further in this document which I have shared. So,
Mhm.
I mean, this is shared with you, all of you. I mean, the link which I have shared in the WhatsApp group, and the WhatsApp description that we have. I mean, we have the link to all of these documents over there. I mean, if you go through them, you'll find this document as well over there. So over here, I have written down the framework or the approach to for any problem, for any design problem. So what we'll do is like following this approach, we'll pick up one problem every weekend. Or I mean,
Mhm.
if most of us are available, we can do it in any weekdays as well. We'll just pick up the problem and we'll just go through all the approach throughout the approach. Like first, gathering the requirements, and then planning the essential features, listing down all the actors, all the objects over there, and
Okay.
then creating a UML diagram, and then we'll the coding part is like basically I mean, depending on the interviews, I mean, it might be optional, it might not be optional,
Okay.
because let's say there are few coding rounds where they term it as machine coding. Over there
Uh-huh.
they'll be checking like they'll be actually checking that, I mean, if you write the code or not, and if you write a workable code or not. I mean,
Yeah.
although it will contain just one small feature only, but they will be expecting you a workable code. I think
Yeah, makes sense.
in Flipkart does has this machine coding round. I think the first
So,
round of Flipkart is machine coding round. So
so they have
that's
machine
what.
coding around for like early career people as well, or just for very senior level roles?
No, 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 definitely not. So I mean, if you are interviewing as a fresher, definitely you won't be getting any system design questions. I
Mhm.
mean, you won't be expecting any system design question. But if you are interviewing for I mean, let's say you have worked for 1 year as an SD one, as an entry level SD1. And then if you are switching, I mean, even if you're switching for an SD1 role only, because I mean within SD1 they have different bands. I mean different companies have their subdivisions within each level. So I mean if you are switching or if you're looking for a role, let's say SD1, but you have some years of experience, then you can expect
Okay, makes sense.
questions around this. For SD2 level, definitely you'll be asked system design questions.
Okay, okay.
Yeah. And coming back to your question, Krupal. So I mean that was what I had planned. I mean if you guys have any, if you want to add any more thing onto this, I think
No,
it's
I think that
more
sounds
so.
good. I
Yeah.
think that sounds good. First, we can focus on the low level design part of it. We can focus on the basics of this, and
Yeah.
then as we progress, we can gradually move on to high level designs, right?
High level design. Yeah. I mean we can I mean depending on, I mean how much clarity, I mean we all want together. Let's say, I mean if you have decided that if you go through 4 or 5 problems together, I mean
Mm-hmm.
we can be more clearer that, like, I mean, if you're designing one system setting together, then I think, I
Yeah,
mean if you are adding something to it, I mean I'll be more clear, like, I mean what all steps I need to follow. Similarly, I mean if the things which I bring on the table, I mean you'll be more clear. Okay, that, like, these are these
yeah,
stuffs which I can add. And I mean if you solve around 5 to 6 problems together, I think it will be more than enough. You can individually then go and design your own system. Uh,
yeah,
by yourself.
yeah. And
So
that's
I
nice.
mean, yeah.
So one
So
more thing I was thinking was about
yeah.
like every time we meet, we'll be doing one topic. Right? Once we cover the basics of it, we can start with the actual problems, right? So whenever we meet, we'll solve one problem, and I'll say that let's take like 6 problems, and each one do like lead one problem, right? Let's say, for example, if we are doing cash next week, right? So
Yeah.
someone will like own that problem. They will come up with a solution and then share that with everyone, because I've seen in these kinds of rounds, like even after knowing the answer, it's very hard to explain your approach, right? So I think
No,
to get that communication
no,
practice as
I
well.
think that's a wonderful idea
Yeah,
that you gave, Krupal, and I think we
yeah,
can definitely work as per that. Like, let's say, I mean, the next for the next session that we have, I think, I mean the problem session that we define whenever we have it. I mean any one of us can take it up, own it up, and they
yeah,
can go through the complete solution, and then we can have discussions.
yeah,
I mean over here. So I
exactly.
think that will be more practical, and I think that will be more helpful for each one of us over here.
Yeah, okay, sure.
And yeah, so that was my thought. And
So
after we go through,
yeah, sorry to
yes,
interrupt. So
yeah,
like Mohammed, as you said, like one person can take up the problem and explain it to others. So usually, why not, like, the problem is solved by each and every person individually, and then they explain their solution to each other. In that way,
yeah,
every person will be working on the problem, and every person will know like what better he could have done in his solution.
yeah, definitely. So I mean, I'll just I mean give you this just one. I'll just tell you about this thing. Basically, I mean in system design, there's no. I mean, obviously, we do follow certain principles and certain concepts, but there is no. A system design question is like an open-ended question. There's no complete right and there's no complete wrong thing. Let's say, I mean if I defined one solution, and if you defined one solution, I mean there may be trade-offs. I mean there will be trade-offs, and we can decide on that. So I mean, yeah, as you said, let's say, I mean we are designing a Twitter feed for the next session, and let's say if you are presenting that, if you will be solving that, I'll be coming up with my solution, and let's say while you are presenting, I mean we can obviously discuss about those trade-offs. I mean that I
Mm,
just mentioned. I think
correct.
that will, yeah,
Yeah,
that will give more clarity, and that will be like I mean we can have good discussions around those topics.
correct. Sure. Yeah, that makes sense.
Yeah, so I'll do make a note of these 2 points, and I'll do share these in the group. Yeah.
And one more question, like, so, what is the timeline period the whole process will go on? Like, for how many days will go with LLD approach, and then how many days will go with HLD approach? And like, what a very high level idea, like what will be covering uh, over this whole timeline? Like, do we have any plan on, like, it like when we started there at the time, like we'll come to know, okay, we should include these and these.
No, so I mean my plan was like quite simple. I mean, as I said before, so we'll first cover with the basics of system design. Like I mean if you see this document over here, the basics of system design, along with the proper approach that we need to follow while in an interview or while working in our companies. And after that, once these session is complete, and along with us we already also have design patterns to go through. If all of us are clearer about the design patterns and the solid principles, the basic stuffs, then I think we can, as Kripal also said, right, like we can have 6 problems, and every session, like today, like tomorrow, we can have come up with one session on like designing a Twitter feed. The next day we can come up on a session like designing an Amazon system. We
Mhm.
can similarly, likewise, we can solve around 6 to 7 problems. And what I think is, 6 to 7 problems, solving together 6 to 7 problems, I think that will give us more clarity and will be more. I mean, if any further any new problem comes to us, I think that we'll be more familiar with how to solve and the approach and everything around that. So,
Oh,
that is what I think, and if everyone thinks the same, I think that will be, we can go on. And yeah, apart from that, if any one of us feels that they want to solve some more problems, then anyone from the group can volunteer to have a one-on-one discussion or any. That's why we have a group over here. So if anyone wants to have some more discussions, some more problems, and definitely anyone from the group can volunteer. I can volunteer, or anyone else can volunteer. So yeah.
makes sense. Completely makes sense. Perfect.
Yeah.
Perfect.
Yeah, after that, post once we complete low level design, we'll go through the high level design stuffs. And I don't think high level design will take much of time. I think uh, that comes with a different set of things. And for me, I think a high level design is a lot more. Not much of the concepts are there, so I think that won't take much time. Yeah. So, and any more questions, anyone?
Yeah, I don't have any more questions. Yeah.
Yeah. So, I'll just we'll just move ahead. And yeah, so we'll just talk quickly about the framework to approach the problem. The first step requires, like, once the interviewer gives you a problem, it can be any problem. The first step that you are required is to gather all the requirements. So you'll basically gather all the key requirements. Let's say, for example, you we have to design a Twitter feed. So we'll go through the key features that a Twitter feed would involve. Like, for example, in a Twitter feed, once you tweet something, all your followers should get whatever the content that you tweeted. All of your followers, all of your connections should get that particular tweet in their feeds. Correct. You'll not be coming up with a requirement like, we can bookmark a tweet, or we can go and change the what do we call that dark theme settings. Definitely, that's not a key feature of a Twitter feed, right? So we'll only gather the requirements that are very key features. Ideally, people say that, if you have the key three to four key requirements, if you gather, I think that would be a good number of points to start, good number of requirements to start. So we'll gather the key requirements and that we want to include in our design, and we'll just write them down. And then we'll have a short discussion with the interviewer, like, these are the things that you want to that will be a part of the system, and these are the things that we would be designing. Okay. The next point, after you are clear with what you are designing, and after you had uh, observed all the key requirements, you'll then go on to identify all the actors involved. So actors basically means, by actors, what do we mean over here is, like, for example, we are designing a system, let's say a school management system or a university management system. So the possible actors over there will be, for example, there can be a student will be an actor, a teacher can will be an actor, correct. Then the staffs, whatever the staffs are there, they'll, I mean, the key actors obviously will be a student and a teacher. Then there will be another actor, can be a head of department, HOD can be an actor. So basically, I mean, we're basically saying the key objects over here. By actor, we basically mean a key objects. And once we identify all the actors, then we'll go ahead to identify the use case, the behavior of each of such actors. So that would basically lead us to define what sort of functionality, what sort of method you need to have for each of the actors over there. Let's say we are, for example, we are designing a school management system. So we have students, we have identified teachers, we have identified HODs. So I mean, the functionality, the method of the students will be like every student will be supposed to be enrolled in one particular class, and every class will have certain subjects, and every student will be mapped to a certain class, and every teacher will be mapped to different classes. And every the functionality of the teacher, the use case of the teacher will be like a teacher should be at any particular at any defined point of time, the teacher will go and teach this class, that particular class. So I mean, that is a sample of a sample use case of the actor, of teacher. So once we had defined all the actors, and once we have defined the use cases of each of the actors, like what functionality each of the actor will be doing, will be performing in the system, then I mean, this will lead you to a basic and a raw structure of your system. I mean, you'll be much clearer about like what what you are building, who are involved, and what are their what functionality they will be doing, they'll be doing over there. So once we are clear with identifying the use cases, the next thing what we'll do is we'll draw a use case diagram. And the use case diagram will basically contain all the actors involved, and the use cases of each of the actor. Let me just check if I can show you a sample use case diagram. uh, okay, I have this link over here. You can, so I mean, yeah, I mean, obviously, I mean, all of the content over here that I have prepared, some I have added and some I have referred from certain website. I mean, I have mentioned all those websites over here. If anyone wants to go have a deeper look, you can definitely go ahead. Yeah. So I mean, can you see the screen, the other screen that I've shared?
No,
Okay, I
Mohammed.
think that's not visible.
Uh,
Let me just share my complete window. Yeah. Now I think it should be visible.
Yes, it's visible now. Yeah.
Yeah, sure. So this is a sample use case diagram for an online shopping system. So if you see over here we have different actors. Here we have different actors on either side of this system. So online shopping is one system, and we have an actor called registered customer, we have an actor called web customer, we have an actor called new customer. Okay. And on this side, on the right hand side, we have different services over here: authentication service, identity provider, credit payment service, and PayPal. Okay. So each of these actors, the registered customer, I mean, the use case, what use case the registered customer has. So the registered customer, the first use case is that the registered customer can view items, view catalog, view items on the shopping website, and then the registered customer can make a purchase over there through the portal. And then we have a new customer. So basically, if you see over here, I mean, I've not gone into the details over here, but I mean, I can understand over here. I think it's. You can also identify this, that a web customer is basically. You can call it as an interface or an abstraction. So a registered customer is a web customer, and a new customer is also a web customer. A web customer can be divided into two categories, right? A registered customer and a new customer. So both of these, registered customer and new customer, are inheriting from this web customer. It makes sense, right?
Yep.
Yeah. So this is a sample a use case diagram. Once we list down all the actors and once we list down all the use cases, we'll just present the interviewer or the person with this. It doesn't has to be very complex. The only idea is like it should be simple, and it should convey the basic idea. What you are building, what actors are over there, and what are the functionalities of each of the actors present in your system.
Okay. So the microservices are also like the actors. Yeah.
Microservices, we don't basically refer to services as actors. uh, the services, we don't consider them as actors. The services will basically have their own interface. This particular online shopping system will interact with, this particular online shopping system will have a different service, and the online shopping system will interact with this authentication service, or this identity provider through some interface. I mean,
Okay.
in one sense, we can call them as actors, but if you talk about this particular online shopping system only, so the only actors we see over here is a registered customer. The two kinds of web customer over here.
Yeah. Okay.
Yeah. So that's about the use case diagram. Now uh, coming back to where we were. Yeah. Once we have the use case diagram defined, we can go and create a class diagram. So a class diagram will basically yeah.
Mohammed, one doubt. Uh,
Yeah.
when deciding the actors, we define two types of actors. One is like the one that registered, one is the new one. So basically, we created a generic class and inherited two classes. Why don't we just maintain a single variable? Why don't we just create a single class which defines as which basically refers to a customer, and within that customer class, we create one variable which says that whether it's a registered or a new, and based on that, its services are defined further. Like, why do
No,
you the concept of
yeah,
the
we
here?
yeah, we can definitely do that. So this particular use case, over here, they have defined it like this. You can definitely, it wouldn't have been required. Let's say, for example, if I was designing it, let's say in my system, if you see, there are certain systems where, until unless you register in that portal, you cannot do any stuffs over there. You cannot do purchase, or you cannot do anything over there. Over
Hmm.
here also, if you see, the new customer can only view items and only register, and
Correct.
he cannot go and make a purchase, or he cannot go and do a checkout. So that's how. Let's say if I had mentioned only one particular customer over here, one actor, and that actor will be responsible for. That actor's functionality will be viewing items, or doing other set of stuffs. And yeah, the question which the point which you said, that maintaining some variable over there. Uh, you can do that, but that's what I said. A system design question is like an open-ended question. If you're able to, based on the basic principles and based on the basic concepts, if you can, if you are able to defend your design, I think then you can definitely go with that. I mean, I
Okay.
cannot say go ahead and say that what you're saying is wrong.
Makes sense. Yeah.
That's what definitely, like for example, if we have a coding question, we can definitely solve that in multiple different ways, and all of them will be correct. So that's how it's over here. This is
Right.
one way of designing it.
But how do we? That's correct. Like, there is no single solution for this. But like, how do we define that? Like, how do we identify like one solution is better than other?
Yeah. So identifying one solution is better than other, we'll basically refer to the basic design principles. So the base, some of the basic design principles say, like for example, a solid principle. If you talk about solid principle, The solid principle says that every class. The first principle of solid principle says that single. It's called as single responsibility principle. So it basically says that any class, any and every class should be responsible only for one thing. I mean, any
Mm.
class should do only one thing, and
Okay. So,
I
so,
mean,
so
yeah,
basically, the person who decides, who basically verifies the solution, he checks whether the solution is designed as per those principles or not. If they are
yeah,
following those guidelines, the solid guidelines, it means that the solution will be like better compared to the other which are not following those guidelines.
yeah. I mean, you're correct, and I'll just add one more last thing over there. So basically, the main idea, why we are doing system design is like, let's say, you're designing one software, and obviously whatever software we design, that is not the absolute solution. Obviously a software is like, not an absolute product. It keeps on growing over time, and it will, people will come and go, and different software engineers will come and work over it. They'll add some features over it and they'll move on. So a software, essentially, you can call it like you can refer to it like a living organism. It keeps on growing in code. The code keeps on adding onto it, the features keeps on adding onto it. And so, just to make sure that, let's say, after some point of time, i mean if the software becomes uncontrollable, and uh, if you do a small change over it, if you add a small feature over it, and the whole code base goes down. I mean, when you're not sure, what where to code properly and how to maintain that. If it starts becoming difficult, then that's a sign of a bad design. So the design principle that we have, we basically follow it, so that we try to basically remain as close as possible to all the design principles that we have, so that, maintaining a software and adding features onto it, and maintaining it becomes easier. That's the whole objective of having system design. That's the whole objective of having solid any design principles or design pattern. Yeah, I hope I answered your question.
Yeah, 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 yeah.
So that's what this is one example of designing this particular system. There can be other different ways to design, and they'll be equally correct. Yeah. So uh, yeah, so where we were, yeah, so we after designing a use case diagram, the next thing, and the most one of the most important thing would be to design a class diagram. So by a class diagram, what we mean is, once you have identified all the every actor, and you have designed the use case diagram, uh, we'll we'll basically list down all the classes that we'll be using. Like, for example, for a student management system, or a school management system, we'll be having a school class, then we'll be having a student class, and then we'll be having a teachers class, then we'll be having a timetable class where we'll be mapping the teachers with the respective classes, so those stuffs. So o- y- so over here, while designing the class diagram, you'll basically define all the classes, and you'll define all the relationships amongst them. How a student class is related to a teacher's class, and how a teacher's class is related to the school class. All those stuffs you'll do over there. And yeah, so that's about the class diagram. The same example, if I have to show, this is how one class diagram would look like. I'll just expand it. Yeah, so there's a web, I think they have used the same example, that online shopping system. So they have a web user, and then we have a customer class, and then we have a shopping cart. Here we see different kind of relationships between them. And you can see for yourself, like, we have defined the relationship between each of the classes over here. Yeah, so any questions around this?
Nah, looks good.
Okay. Okay, so once we have the class diagram designed, there may be counter questions around uh, I mean, around the relationship that you define over there. and based on that, I mean, you can defend your design, like why you have related, I mean, how you have related, how you have defined the relationships between the objects and the classes. So that's about class diagram. And the last, I mean, after you do all of these, then you'll be proceeding with the with writing the code based on the use case diagram or the class diagram. I think if you follow the class diagram, I think it will. When once you are clear with the class diagram, I think that makes it very easy to go ahead and write the code, because I mean that is, and I mean that is how we relate when we write code. I mean we basically write code in terms of classes. So once you have the class diagram ready, then I think it will. I mean, it will be more than 60 to 70% of your problem is solved over there. Writing the code, basically you'll basically start with interfaces or abstract classes, obviously. And when, I mean, as I mentioned earlier also, when you are writing the code, I mean, when you're writing down the solution, I mean, we don't need to go into very details of the system. I mean, whatever the key features that we had defined, we'll just go through them. And I mean, if you think it like this, like designing a complete Twitter feed or designing any particular system in 1.5 hour. I mean, obviously, I mean, that's not a possible thing. Definitely, I mean, a system like a Twitter feed or a system like a school management system is quite complex, and we cannot design everything around in 1 or 1.5 hour. So we'll basically only write the key features, and I mean very simple stuffs over there. We won't go into and much detail until and unless the interviewer specifically asks for it. And once we have written the code, I think that would be more than enough. You can write the implementation part over there, like, and once you have designed the solution, you can just create a few objects in your main method, and you can just do the sample interaction. I mean, how they will be interacting or how the process will work. You can just do that. And I mean, if you still have some time left, you can definitely go ahead and write some unit tests over there. I think this is completely optional. I mean, not only optional, I think this is not required. But I mean, once you reach this till this part, I think that will be more than enough for the interview or for the system. So any doubts or any questions around this approach? I mean,
So
moving ahead.
one
Yeah.
question. So
Yeah.
will the interview will just tell us like, okay, go ahead and design Twitter feed, or like will it also tells us like, okay, so and so features needs to be present?
No. So the interviewer will basically give you a problem statement. The interviewer will give you a problem statement, like for example, they might tell you that you have to design a system like like a Dropbox, where you can, I mean, whatever the local work you do, you store in one folder, and that you can access it remotely also. I mean,
Okay.
it will be just a problem statement, like you see in coding questions. But since I said earlier that, like, in system design, I mean, we don't have any there's no absolute answer over there. So what our job as an interviewee will be, like, we'll have to talk with the interviewer, and we'll have to ask questions to him or her. We'll basically, I mean, whatever doubts we'll have, we'll have all our clarifications cleared. I mean, in the requirement gathering step. I mean, once we start writing down the requirements, I mean, gathering the requirement basically means that, I mean, we'll ask questions to the interviewer, like, okay, let's say if they ask you to design a Twitter feed, so you can basically ask him that, like, I mean, this is the number of users that you are expecting to be in your system. Let's say you say that, I mean, I'm expecting like 100,000 people will be using this system, so I'm designing the system for 100,000 people. So I mean, if the interviewer is fine with that, he'll say it. I mean, he'll say it. Otherwise, if you want to ask some more questions, like, I mean, if you want to ask questions like, will my Twitter feed involve uh, do we have a celebrity problem over there, like while you design a Twitter feed, there's a specific problem over there, we call it as a celebrity problem. Because I mean, what Twitter does is, like, I mean, if you're a normal Twitter, I mean, if you are a normal person on Twitter, then you won't be having much followers. But a celebrity will be having, I mean, millions of followers. So the fan out service that we have over there, while fanning out I mean the Twitter feed for a celebrity, that they have categorized it as a special case, and they call it a celebrity problem. So you can ask the interviewer that, I mean, do we need to write the code for celebrity problem also? So all those clarifications, whatever doubts you have, you can definitely put that up with the interviewer, and the interviewer will clarify all such doubts. I mean,
Okay.
that's why we have this step. And after this step, you will be basically, after the requirement gathering, you'll be, whatever doubts you have, you'll clarify all those with the interviewer, and then you'll be like completely clear that okay, this is what I have to design finally. Then you'll sit down and you'll follow the next steps, like identifying the actors and the use case for each of the actors involved.
Makes sense. Makes
Yeah,
sense.
yeah, yeah. So moving ahead, I mean, in further sessions, we'll basically follow this approach, this short little approach to design all the systems. Whenever someone comes up and we'll be discussing the solution. We'll basically list down all the requirements. We'll basically show that like these are the requirements which were there for me, and these are the actors I had identified, and these are the respective use cases for each of the actors involved. So similarly, I mean, we'll follow these steps, right? Yeah. So I think we are done with the basics of low level design. Uh, we can move ahead now to uh, basic stuffs. Okay, the basic stuff, the prerequisites were over here. Like, okay, so I mean, anyone over here, I mean, who wants to discuss any of the topic from here, like OOPS concept? I mean, we can discuss.
Yeah, it will be helpful. Like if like I'm not good at those. So if someone can explain, or it will be like good recap.
Okay, sure, sure. Anyone over here would like to go ahead with discussing any of these? I mean, one topic we all can pick up from here: abstraction, encapsulation. Anyone would like to discuss?
Yeah, I think I can pick up inheritance and polymorphism.
Okay, okay, Gopal, you can go ahead if you want.
Um, all right, actually, I'll need some time to think. Like, just give me 2 minutes, okay?
That's completely fine. That's completely fine. I mean,
Okay.
it's not an issue.
So you
You
want
want me
me
to
to?
start with any of the topic, and then you will pick up?
Yeah, I think that would be good. Yeah.
Okay, okay, that's fine. No issues. So, so basically, I'll start with so classes and object. Do I need to start with anyone wants me to start with classes and objects?
No, I think we can skip that. Right? That's fine.
We can skip that. Okay, okay. Yeah, I mean, in short, I mean, when we talk about an object oriented programming, so the basic pillars you can see about there are like we do everything in terms of classes, and classes are nothing but a blueprint of the real thing. That real thing is basically an object. So an object will basically have all the characteristics and all the behaviors of how its blueprint was. So that's about classes and object. And if we talk about abstraction, so basically abstraction basically means uh, representing all the essential features without explaining the background details. For example, I mean, if I talk about an example, let's say we have a car, and you know that let's say, I mean, while you are driving the car, you just know. I mean, the interface that you have is like you have an accelerator, you have a brake pedal, and then you have a clutch pedal, and the other thing that you have is your steering wheel. I mean, you don't know what is going behind that particular thing. You don't know what is going behind. I mean, when you press the brake pedal or when you press the clutch pedal, you don't know what is going behind. All the common, I mean, not common, but all the unnecessary stuff that that you shouldn't be bothered about as a driver. You shouldn't be bothered about that. All those are hidden from you. Okay, and I mean, that is from a driver point of view. I mean, if you're driving a car, that is from a driver point of view. Let's say a mechanic comes. Okay, let's say your I mean, some issue happened with your car, and the mechanic needs to look at your car. So from a mechanic's point of view, I mean, he isn't concerned like what kind of seats you have, or what kind of color you have in your car. He'll open the bonnet and he'll inspect his his stuffs. He's basically concerned about, I mean, how the air filters are working, or how the what is the level of the engine oil, those stuffs, right? So abstraction basically means like, from a perspective of any actor, I mean, that particular person or an actor should only able to see what details he require. Like, if I'm driving the car, I only need to be concerned with where my brake pedal is, where my accelerator, where my ABC pedals are, and where my steering is. How am I able to move those stuffs or not? I am completely not concerned about what is going in the background. So that basically refers to abstraction. And implementing abstraction. So yeah, just one question I would like to ask. I mean, all of us over here are comfortable in Java, is it, or any other language do you guys prefer?
Yeah, I'm fine with Java.
I'm actually comfortable with C++.
I'm comfortable with JavaScript.
JavaScript. I mean, is it
Yeah.
fine? I mean, is it fine if you use Java for reference, or
No, actually, I am fine with Python and JavaScript both actually, but
okay?
not much too much in Java actually.
So I think if you're doing classes in
Okay,
Python, I think it'll be fine, I guess.
Yeah.
Yeah, the idea is to just like come up with the
Yeah.
abstract classes and coding work. So I think that should be okay, I guess.
yeah, I think that should be okay. Yeah, so I mean, implementing abstraction, what we basically do is like, what we do is basically we have certain abstract classes. And as we know that abstract classes will only, I mean, inside an abstract class, if we define a method, and a method as an abstract, so it won't be containing any body over there. It will just be like a contract. Like any class or any other entity that is implementing, or that is inheriting that abstraction, so it will have to implement the body of that particular uh, abstract method that is defined in the superclass. Okay, so basically abstraction basically will let you enforce certain stuffs over there, certain characteristics, or certain behaviors. So I mean that is how we basically do abstraction, with respect to the code. um, if you go about next, the next thing is
Mohammed,
basically,
Mohammed, I have one doubt actually for the
yeah, sure,
abstractions actually.
yeah, sure,
So just like we have one, and just like we have an example like just like vehicle or the car. In
okay,
there we can show only the running functionality,
yeah,
key what is the vehicles and some other part. But when we just create the classes for that one as an abstract class for hiding the information and showing only the some functions. So I'm just asking one thing that key, we will create only the that abstract functions in there. We will have to be show to the users only. Yeah, we will have to be abstract the hiding functions.
no. So what we do is, so Shivam, what we do is, uh, whenever, I mean, so we basically have, I mean, whenever we write code, we basically have I mean, a client code that basically interacts with our code. And the code that we have all the business logics over there, and all the business logics, and all the whatever classes or objects that you have defined. So the client code will interact with your code and will do, I mean, it will do some stuff, it will do some work. So when you write your code, the client code should not, I mean, should not be concerned with what is going behind your code. Let's say, for example, I mean, I'll just give you one small example. Let's say, uh, let's say I mean, you have a delivery company, and you basically deliver parcels. And the different modes of transport that you use is, let's say you use transport by air, and transport by rail, and let's say transport by road. So I mean, let's say, I mean, if the client code is, I mean, if the client requests you, sends you some parcel, and they will just say you that, I mean, I want to transport this parcel by road. So the client should not be concerned about like how you are doing that in the background. So if you have a class, so I mean just consider this. I mean if the client comes with a by road transport method requirement, so what you'll do, you'll provide an object for the by road class, correct?
Yeah.
And if the client then comes next, and I mean another client comes and asks you for a by air uh, transport by air functionality, you'll create an object for the transport by air. Let's say, I mean, you have defined these three mode of transport. Let's say tomorrow some certain other, some 10 different modes of transport comes for you, then you'll not go and write. I mean, obviously you'll have to write different codes, but then your client code will sort of get coupled with your business logic, so it shouldn't be coupled, like, right? So what over there, what you'll do is you'll basically have an abstract class or an interface, and the client class, that abstract class will only have a method like transport. It won't be have a method like transport by air or transport by road or transport by ship or whatever. It will only have a method like transport. So what the client code will do is the client code will say that I want to transport by air, and he will just call the transport method of the abstract class or the interface. Okay,
Okay.
and based on
That part,
whatever, yeah,
that part I understood
okay,
behind the logic about the abstractions, but actually I was confused related to the how we create how which functions we will have to be provided as a abstract. Just like let me give you the one example also. Just like we have one car, right? And
yeah,
we are providing the functions like one brake function,
yeah,
and second is the running function, right?
okay,
Whenever
okay,
user will just click on the brake, it will just stop the car, right? So
okay,
stopping the car, and all these functions is running in the behind. So and the brake function will be accessed by the users, right?
okay.
So we will provide the abstract function as a brake or running. Actually, I was confusing regarding that one.
No, no. So I'll just give you. I mean, I'll just talk about this. So basically, let's say you have a break. I mean, you talked about the break functionality, and the users. I mean, the user. I mean, what as a user, what do you have? You only have the brake pedal, right?
Yes.
You don't know. I mean, as a user, as a driver, we have completely no idea. Like, I mean, is the brake? I mean, if it is a disc brake, or if it is a drum brake, or if it is some certain another technology involved in that brake, we don't know about that. I mean, obviously we know that, I mean, there's a disc brake present in our car, but we don't know how the functionality is over there, right? We just need to press that brake pedal. So
Yes.
let's say today you have that three different kind of brakes available. Tomorrow, I mean, after the technology evolves, we have some 100 different kinds of brakes, kind of brake technology. So what we'll do is we'll have that interface, we'll have the brake thing abstract, and if new different sort of brake technologies comes around, you can simply you can simply implement that brake functionality. You can simply implement that brake functionality or the brake class, and they can go ahead and implement their own different functionality within that function. You can override that method, the brake method. You can override, and you can write your own method over there.
Okay.
Okay.
Okay. Okay.
I mean, is that? I mean, was that clear enough for you?
Yeah. Yeah.
Okay.
Yes.
Anyone else who has any doubts? Okay. Uh, I'll count it as no. And so the next thing over here is like encapsulation. So what basically encapsulation means is like encapsulation basically refers to hiding the data from the outside world. I mean, in very layman language, you can say that hiding protecting your data basically. And I mean, how we do that in I mean in code is like we basically, I mean, if I talk about Java, or I mean, I think that will be relatable to other languages as well. In any language, you'll declare your class variable as private, and then I mean, for exposing that, I mean, once you declare it as private, that that particular variable or that particular data, I mean that will be accessed only within the class by the method of the class. You cannot access it from outside, from any other class. So I mean, how you will expose it? Like you will expose it via getters and setters. I mean, let's say you created one variable, class variable, you'll declare it as a private variable, and then you'll add getters and setters. So the outside, I mean, the outside object, if they want to access, they'll access via the getters and the setters method. So that is what encapsulation is basically. I mean, it's any questions on that? Anyone?
How is it advantageous?
The advantages of encapsulation, you can say that, I mean, if you have a private variable, I mean, if you have encapsulated properly, uh, it will basically help you in designing better systems basically. So that, I mean you are very sure. I mean, there can be times where you are accessing an object and you might accidentally go ahead and change the variables over there, I mean, do some things over there that may that may pollute that particular object. And you can accidentally go ahead and modify the private variables that are not required by some other objects. Okay, I mean, accidentally that can be done. And once you declare your once you encapsulate your classes properly, then you know that, I mean, you have proper getter setters to use. Let's say if I don't want my, I only want my like, let's say I have a class and I don't want that that variable, that class variable, to be modified. So either I'll declare it as, I mean, either I'll remove that set method. I'll remove the set. I won't apply the setter. I mean, you can only fetch the value, and setting the value, like, let's say, depends on some particular calculation that won't be exposed, that shouldn't be exposed to any object. So I'll set the value via some calculation. I mean, it might depend on some certain other variables. I mean, some particular calculations are required to set that variable, and I don't want the other objects to have that functionality to set that object's variable. So I'll remove the setter method. So that's how you can properly encapsulate. I mean, that the first benefit is, like, I mean, you can have a more reliable code, you can have a more robust code. And if there's some I mean, if you're debugging, that will be like easier for you to go ahead and debug. I mean, if your code involves some bug, it will be easier for you to go and debug and find out the actual issue. I mean, it makes your code basically simpler, and basically makes your code more reliable and more robust. I mean, less bugs over there.
Okay, okay, okay.
And anything anyone would like to add on that?
Yeah, actually, as from my point of view, whenever we the data or the class will be the encapsulate, then we can hide in everywhere. We can remove key. Anyone can change in any functions. And the
Okay.
second thing is that key, the data or the class will work as a flow. Means like. Only that part of the actions performed by only the child class only, yeah, only within the functions they can just work on change the parameters. Otherwise when we will just we can decide the public to the all, then we can change we can just call the variable and change it from everywhere, so
Yeah, correct,
that
correct,
create the issue actually.
correct. So you're basically talking about the access modifiers, right? I mean,
Yes,
the
yes,
controls that we, yeah, the controls that we have over any variable. Yeah, so
yes, yes.
that was a good point. Yeah, we can basically, depending on your use case, you can have different levels of access modifiers. So that was about encapsulation. Next is inheritance. Krupal, would you like to go ahead?
Yeah, sure. Actually, can I share my screen?
Yeah, definitely. I mean, you see the
uh,
option over there. You get the option to share.
I think I do. Let me see.
Yeah. Just
So,
toggle from there. I'll stop.
okay, I think you need to stop. Yeah. Okay.
Yeah.
Screen sharing failed. Something went wrong. Oh, I think I do not have the permission to share my screen, I guess.
You should
Will
be
you be able
having.
to grant?
Let me check. I think I don't have. I mean, I don't see it in under moderation controls.
I think in settings you can.
Profile monitor. Yeah, we can see your screen. I think.
You can?
Yeah, we can see your screen.
No. I just check. Like I can share,
No,
so Drupal you can also share. Or you are the
no.
main.
I think it's Jitin who's sharing his screen. It's not me. Yeah.
No.
So let.
It's um, I just share to check whether we can share or not.
Oh no, it says that screen sharing failed. Something went wrong with your screen sharing permissions.
Okay.
Uh,
I think that
You
browser
on MacBook?
you might have to enable the
Sorry.
you check in your browser search bar whether there is any pop-up which is disabling the.
Uh, yeah, hold on. Let me see that. I can't see anything. So I'm getting this message from the this thing
Basically,
itself.
yeah, I don't have any. I mean, controls like. I mean, I don't control. I mean, who can share or not. So.
Actually, just give me 1 minute. Settings is preferences. Sometimes I hit this. Oh,
I
come
mean,
on.
do you want to share some link?
No, actually, I want to share a whiteboard.
Okay.
So,
Okay.
yeah, because I cannot explain directly. I need some sort of whiteboard to
Okay.
explain things. So, yeah. So,
More.
okay, let me try again. I cannot see that option now. No. Actually, let me join back again. So let's see if
Okay.
that
Okay. Okay.
can just send. Okay. Let me.
So Gopal, this is your screen, right?
Yeah, whiteboard, right?
Yeah, we can see the screen. Yeah, tutorialspoint.com and whiteboard. Yeah.
So I see it as a very red in color. So are you looking? Are you seeing it properly, or it's a weird color?
No, I'm able to see it properly.
Yeah, it's
Properly whiteboarded. It's proper
Yeah,
whiteboarded. Okay,
properly white.
because I'm
Properly white.
okay because I see it as in the video. I see it as very red. Okay, that's fine. Okay, that's fine. So okay. I think first I'd like to talk about inheritance. So let me give an example, right? So let's say we have a class called file, right? Let's say we have a class called file, and that has methods like like get file name, right? Get file name, maybe set file permissions, right? Set file permissions, uh, so on, or maybe some other kind of method, right? And we also have some other variables like maybe string file name, right? So, and we have one method called as process file, right? So let's say we have something like this. If you see get file name, set file permissions, file name, and these three things, right? These three things are pretty much common to every file type, right? Like for example, if it's an XML file or a JSON file or a CSV file, right? These three permissions, these three methods, and what this one variable, these things are
are going to be common for every kind of file, right? So what do we do in this case is, let's say, but this file, this method, a process file, this process file method is not going to be same for all the files, right? Because let's say if you are reading a CSV file, that process file method might be different, or if you're reading an XML file, that process file method might be different, right? So what if you want to provide your own process file method for some other file type, right? So in this case, what we do is, let me clear this out. In this case, what we do is we inherit all the things that we have in file, and then we override the process file method. So basically the idea is, let's say if we have a class file, we inherit our own type of file from this class file. So let's say if we want to write a separate process file method for like XML file, right? Or maybe CSV file. These both classes, they'll both inherit the three methods, which is get file perms and set file perms, or string file name, right? These two classes will inherit like all three properties from this method, from this file class, and they can actually go ahead and like override process file method, right? They can override process file method in their own way, because XML file processing might be different than CSV file processing, right? So yeah, so this is the idea of inheritance. And we say, when we talk about inheritance, it just basically means that we basically inherit the properties of our parent class. So in case of XML file, the parent class is going to be file. So basically the idea is, so we inherit the properties of a parent class so that we don't need to redo them again, right? Because get file permissions, set file permissions basically will have the same code, right? Not different code, right? So why do we need to repeat yourself when you can just create one parent, like put all the common things in that parent, and then we create individual subclasses, and then just override the specific methods for those subclasses. This helps to maintain our code, right? We are not repeating ourselves, like we talked about in solid principles. The first thing is single response, not single response. I think don't repeat yourself principle. I know there was some dry principle. Yeah. This is called as dry principle. What's happening? What? Okay, I'm trying to get used to. Actually, hold on. Let me. Okay, yeah. So basically, this can be put into dry principle. When dry says that don't repeat yourself. In this case, we are not repeating ourselves because we are putting all the common utility methods in our file class, and then we are just inheriting from file class and just writing our single process file method for each of the subclasses that we want, right? So any questions do you have here?
It's
I'm good.
Yeah, looks good, right? Okay, right. So let's move on to polymorphism, right? So are you all familiar with interfaces?
Yep.
can you explain if it's okay?
Yeah, sure. So let me do an interface, right? So interface, let's say I have an interface called a database, right? Let's say my interface database. Okay. So interface basically means that whatever you have in your interface, you don't really provide an implementation for that, and you basically depend on the class that is implementing the interface to provide that to provide the implementation, basically, right? So let's say if I have an example of database. So let's say we have an interface for database, right? We know what methods database class should have. Like say read, right? Read. It can have right, update, delete, right? So we know that a database class must have these 4 methods, right? But we don't really know like how we are exactly going to implement this read, write, and update and delete methods. But we know that that database must have these 4 methods, right? Because every database we basically read, write, update, and delete, right? Um, so yeah, so basically a database must have these methods, but we don't really know what the implementation of that method is. So what we do is when we create an interface, we just declare the methods like this with the return type, of course, right? Sorry, void will have some. For now, I'm writing void. It's not going to be void, right? Like we declare the methods like this, and we just do a semicolon here saying that okay, we don't really know what the implementation is. We are going to depend on the class that is implement this interface to provide an implementation, right? Any questions here?
So the return type will be always void for any
No,
function.
no, not really. The return type really depends on what you are returning, right? So in case of read, we are going to return something back, right? So it can be a list of something, or it's not necessary to have void. It can be anything basically. It can be an int, it can be an object, it can be anything. I didn't know what to write for read, so I just did a
Okay.
void there. But it's so let's say if I have an database, right? So
And,
let me
and
write this down again. Yeah, go on.
and can the interface have the member function? Like we have member functions, can we have the properties also defined?
You can have property defined there.
Okay.
Yeah. Yeah, I think one thing to remember is whenever you define a property in in an interface, that property is by default final, if I'm not wrong, Anas. Right.
Yeah, definitely. So
Yeah.
this is with respect to Java. I mean, in Java, it is like by default is final, and
Yeah.
depends on other language. I'm not sure about other language, but yeah, it
Yeah.
depends on language to language. There will be slight stuffs here and there, but more or less, it will be same.
Yeah.
Yeah.
Yeah. Okay. And there's a reason behind that, right? Because let's say, let's say we have an interface for a car, right? The car is going to have just one steering wheel, right? So you can have num steering wheels as one, because we don't want the classes implementing that interface to add any more steering wheels, right? So we need just one steering wheel. So that's why they're always final. So you guys are familiar with what final is, right?
Not exactly, but it's okay.
Okay, sorry about that. Okay, okay, I'm sorry about that. So let's say we have an int age is equal to 7, right? You can go ahead and do age is equal to 8. You can go ahead and do age is equal to 9, right?
Correct. Correct.
But when you do final int age is equal to 7, if you do something like this, you're going to get a compression error. You can't really change the value because you're saying, hey, if the value of age is 7 and it's final,
Okay.
you cannot change that. Yeah,
Okay.
that's why.
Okay, yes.
So it makes sense, I think, in terms of interface. The variables are always final because you don't want the class implementing that to do some funky thing, right? Like the example I gave for car, there should be only one steering wheel and it should have at least one steering wheel. You can't have it at 0 or 2 or 3 or whatever. There should be just one steering wheel. Otherwise, it's going to be a very bad car, right? So yeah. So clear with this?
Yeah.
Okay. So let me do that again. So let's say we have an interface database, right? There are so many different databases, right? So what we do is in the interface, we just declare these methods called as read, write, and so on, right? We don't have an implementation for that. We just do a semicolon saying that, hey, please implement those methods. So let's say we can have 2 types of databases. One is MySQL, one is Postgres, right? So let's say MySQL implements this interface. The syntax to do this is like class MySQL DB implements DB. Okay, for short, for just concise purposes, I'm writing this as DB. Okay, so as soon as you do something like this, it says that your MySQL DB is implementing from database. As soon as you do this, this is going to throw us an error because it's going to say, hey, please implement all these methods from database. So you must implement, otherwise your code is not going to compile. So what you need to do is you need to implement your read method, and you need to provide some way of reading. You need to implement your write method, and you need to provide some way of writing, right? So that's how interfaces are powerful, right? Let's say if you create an interface and declare some methods, all the classes implementing that interface must have an implementation for those methods. Otherwise, it's not going to work. So that's how you make sure that you always have an implementation for read and write methods in your database classes. Any questions do you have here, or is it confusing?
So this validation happens at compile time.
It's compile time, yes. So as soon as you do implements DB, right, it's going to start throwing an error and saying, hey, please implement all these 4 methods.
Okay.
And you cannot just not implement those methods. As if you decide, hey, no, sorry, my database doesn't have delete method. Sorry, that's not possible. You must have a delete method. Right?
Okay.
Okay. Any questions here? No? Okay. So let's move on to polymorphism now. So polymorphism basically says that in Java, you know what you do. It's like, let's say if you have an example of MySQL DB, MySQL DB. When you want to create an object for this MySQL DB class, what you do is MySQL DB is equal to new MySQL DB, right? Do you guys know the syntax?
Yeah.
So what this syntax really means is that whenever you create an object, you always refer to them by this class name, right? Because you're creating an object of MySQL DB class, you are going to refer that object by this MySQL DB class. That's how we basically do it. I think in almost all the programming languages, I think. But yeah. But what polymorphism says is that it's not really necessary for you to use the same reference as the object class. You can use any reference as long as that reference is the parent of that class. Okay, so let's say, for example, if you have like class A, and you have a class B as a subclass, then you have a class C as a subclass, right? You can do B is equal to new C. You can do A is equal to new C, but you can't really do B is equal to new. You can always refer your object by your parent class or your grandparent class or so on, right? That's what polymorphism says, and I'll just give you an example of how this is so powerful. But do you guys get the gist here?
Yeah.
Okay. So let me tell you how this is so powerful, right? So let me give an example. So what we had an interface DB, right? We have an interface DB. We have all the methods defined here. Then we have MySQL DB and Postgres DB as your classes which implement this interface. So it's not really necessary for polymorphism to just be with class. It can be with interface also, because technically this interface DB is actually a parent of MySQL DB and Postgres DB, right? So technically you can use this also. Let's say we have a class called as database service, right? Database service. This database service class basically just implement some service methods, right? Now, let's say in this database service class, you had a method called as fetch data, right? If you have a method called fetch data, this fetch data method needs a database object to actually go ahead and call the read method, right? Because these classes are going to have the read method in them, right? So fetch data method is actually going to need an object of these two classes, right? So let's say if I do MySQL DB as MySQL DB, right? If you do something like this, this means that your database service always depends on MySQL database, right? Let's say if you wanted to extend this to Postgres DB, right? What you'll do, you'll have to again write the same method, fetch data, and then pass a Postgres DB here, right? And if you add like 10 more databases in future, now you have to have like 10 different methods here with 10 different database types. With polymorphism, this becomes really powerful because you can, instead of having, actually, let me erase this. Okay. Oh, come on. Now with polymorphism, this becomes really powerful because what you can do instead is your fetch data method can just take in an argument as database, and you can just call db.read, right? You know that db.read is going to exist because database is an interface, right? Since database is an interface, you know, like all the classes which inherit that database interface are always going to have this read method, right? You can guarantee that. So this becomes powerful because when you create a database service object, you can call this fetch data and you can pass whatever the database you want, whatever database instance you want. Let's say if you are working currently with MySQL DB, right? You can just do a new MySQL DB, and you can just pass this object here in the fetch data method, and it's going to work because you know that MySQL DB inherits from DB, and it's going to have this db.read method, right? Because technically you can do something like database db is equal to new MySQL DB, or you can do database db is equal to new Postgres DB, right? You can pass db1, db2. You can pass db1 to this method, or you can pass db2 to this method, because technically MySQL DB and Postgres DB are subclasses or or a child of database, right? Any questions you have here?
Why don't we pass? So since we are
Yeah.
passing object to the database service method, fetch data method, why don't we uh, uh, pass the object? So like when we created the object, we created the object of an interface like database DB1, database DB2.
No. We create so one more thing about interface is that we cannot create objects of an interface. We can only create objects of classes. So this is an interface, this is a class, right?
Okay.
Here, when you look at this, right? When you look at these two, these are objects of their individual classes. So this is an object of MySQL DB, and this is an object of Postgres DB. But we are referring that object from their parent, which is database, right?
Mm-hmm.
And this is helpful because in this case, right?
Mm-hmm.
If you refer the object by its parent, you know what methods the parent has, right? You know what methods the parent has, and you can just call those methods, because if the methods are going to be there in parent, the methods are obviously going to be there in the children, right? You're getting where I'm going with this.
Correct.
So you see that, right? So since your MySQL DB is implementing database, your Postgres DB is implementing database, you know that both these classes are going to have read methods, are going to have delete methods, write methods, create methods, right? So here in this fetch data, you don't really know which class is going to implement database, right? For this class, it doesn't really know which class is actually going to go ahead and implement this interface database.
Correct.
All it cares about is this read method, write method, delete method, whatever method, right? Whatever method this database has, right? And whichever class which implements this database interface, it's going to provide some implementation for the read, write, and whatever methods, right? So
Correct.
technically, when you do db.read, if db is an object of, if db is actually db1, right? If db is actually db, so let me just to make it clear, right? So in our, let's say this is a database service which has this, fetch data db, right? And it basically just does db.read. Now let's say we have something like db1 is equal to new MySQL. Yeah, we do db2 equal to new Postgres. Yeah, and now whenever you call this fetch data, we can either pass db1 or we can pass db2, right? So this fetch data doesn't really care which database you are passing, right? As long as you are passing something of type database, which is like MySQL or Postgres, as long as you're passing some child of this database interface, it doesn't really care which objects you are passing. So are you passing MySQL? Are you passing Postgres? Because this only cares about reading, right? You know for sure that whichever class which implements this database interface is definitely going to have this read method, because that's what we mandated, right?
Correct. Yeah.
So
Now,
so this is a part. This is called as polymorphism, right?
if,
Whenever you sorry, go on.
so like to make it generic. So in case if you have multiple DBs, and
Yeah,
if you want to call the read function
yeah,
of all the different DBs, but we don't want to have the separate fetch data functions for all of them, then basically
exactly,
we can create one interface, and we can we can like create an object of all those classes, but map it to an interface. And then if we
exactly,
pass the interface as an argument to fetch data, then it becomes like a single function to call the read for
exactly.
every device. Makes sense.
Exactly. Yeah. So not necessarily you have to, whenever you create this object, not necessarily you have to use this syntax. You can also use MySQL is equal to new MySQL, right? And you can still pass this MySQL here, and this is still going to work because technically MySQL is actually database, right?
Okay.
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 So if you create objects of MySQL like this, or if you create objects of MySQL like this, you can still pass, instead of doing db1, you can pass MySQL, right? And it's still going to work. So this is the idea of polymorphism, right? The polymorphism basically says whenever you can actually refer your objects with your parent class. That's the whole idea of MySQL, and this is how it's used in real life practice.
Makes sense. Yeah.
Yeah, so whenever, so let's say in whatever system you are designing, right? Whatever system you're designing, if you're using a database, you must use a pattern like this, where you create one interface database and then you just keep on adding. Like for example, Spring Framework, right? With Spring Framework, you don't really know which database you are going to use. Like whatever backend framework you use, they don't really care about what database they are going to use, right? But they know that any database you use, they are going to have read, write, update, and create capabilities, right? So in that case, what they do is they create an interface of database, and then they, for each database that is out there in market, right, they provide implementations for that database, and then you can actually create this data method, just one fetch data method, and just do db.read. You know, yeah, that's that's how that's how polymorphism works. Any doubts?
So Krupal, I don't have any doubts, but I would just like to add a few points. I mean, on what we covered so far. So, I mean, this is also known as, the thing which you discussed right now. This is one type of polymorphism, and this is also known as method overriding. I
Yeah,
mean, yeah, and there's a different kind of polymorphism that is also known as static polymorphism or compile time polymorphism. That is basically, method overloading. I think most of us would be knowing. If you don't know, we can discuss that as well.
yeah. So do you want me to discuss method overriding or method overloading, or do you guys are clear with what that is?
Yeah,
It will
Krupal,
be good if
I
you
want
can.
one thing also. Ki,
Yeah.
in the initial you said ki, we need the interface. So only we can use only polymorphism only for the interface. Yeah, we can
No, you can use it for class
and
also.
next step. Okay.
You can do it for class also. Let's say if you have class A, class B, and then you can do A is equal to new B, where A is a parent of class B, right?
Yeah, yeah.
But you cannot do vice versa. You cannot do like child is equal to new parent. You can just do parent is equal to new child.
Yeah.
You can always refer to your parent, not refer to your children when we're
Yes. Yes.
recording your objects. Yeah.
Yes. Okay.
Yep.
Yeah,
So do you
Krupal.
want?
Yeah,
Yeah.
yeah.
Go on.
That will be helpful. Like if we can also discuss the overriding and overloading part.
Sure. Let me clear this up. Okay. Let me.
Just one thing, Krupal. I think it was Jatin or Shivam.
For
Just,
overloading and overriding.
Yeah.
That
So I mean, what Krupal explained just now. This was overriding.
yeah.
okay, okay.
This was overriding.
So
Yeah.
yeah.
Yeah, Krupal, go on.
So overriding. So overriding simply means that whenever you have some method in your parent class, let's say class A has some method, right? And then class B inherits from class A. That method automatically gets added in B, and you don't really need to like specify that method here in your class. But let's say you are not really happy with that method from class A, and you want to provide your own implementation. That's when you like just use the same signature as what the class A has, and then you can just write the same method here, and then provide your own implementation to that method. And this is method overriding. What method overloading really means is come on. Okay, so let's say you have maybe some class. Let's say what is the good example for this? Hmm. Okay, maybe let's say class sum, right? This is not a good example, but I'm just going to add like class sum. Sum. Let's say we have a method called as uh, public int add, right? A, B, and C, right? Where you just add A plus B plus C and return that. But what if you don't want three variables? What if you want just two variables, right? This is not going to be possible with this method. So what you do is basically just do public int add, just change this to like A comma B, right? What we are doing here is in the same class is basically you have the same signature for this. If you have the same return types and same access modifier for this method, the same method name, but the only thing that is different is the number of parameters, right? So this is the idea of method overloading, where you have the same method name, but you have a different. Either you have a different return type, or you have a different number of arguments or different types of arguments. For that example, let's say if these are all ints, int. This can be a float. This can be a int or float, whatever. So this is the idea of method overloading, where basically in the same class you have same method name, but you have either different return types or different arguments types, or maybe different number of arguments, or both are different in this case. But you cannot have something like ABC where all these things are the same, right? You cannot do that. You have to have something different in the same method name. Any questions?
Clear. It's clear. Yeah.
Okay. All right. Is there anything that you guys would like me to talk about?
Yeah, Krupal. So I think I think it's 7:10 over here. So I think
Yeah.
we are slightly over the time, and I mean, if
That's
it is
fine.
fine with everyone, yeah, if it is fine with everyone, we can go ahead. Otherwise, we can,
Sure.
yeah.
I can
So,
actually
I mean,
stop sharing my screen. Yeah.
yeah, if everyone is fine, we can go ahead and discuss some more topics. If everyone
Yeah.
is
Yeah.
fine.
Please.
It's fine with me.
Yep.
Okay. Cool.
Yeah, I think I can stay a bit longer if you guys are fine with that.
Okay, sure. So I mean, we can we can stay for another 10-15 minutes, and we can discuss, and then we can wrap up.
Okay.
Yeah. So the next, okay, I'll just go and share my screen. Yeah. So the next thing that we have in line, that's basically association and association, aggregation, and composition. Okay. So What do we mean by association? Uh, basically, association basically defines the relationship between different objects. So, I mean, we have different kinds of association like one to one and one to many, and it basically defines the relationship between different objects. I mean, if you see over here, there can be one to one, one to many to one, and many to many relationships between objects. And I mean, if you remember earlier, we were discussing about while we were discussing about that the approaches for any system design interview, any system design problem. So we discussed over there that we'll have to draw a class diagram. We'll have to come up with a class diagram after we identified all the actors and the use cases. So when we come up with the class diagram, we'll have to define the relationships in between those classes. So let's say a very basic example. There's a student class, and there's a student, and there's a college class. So one college can have multiple students, correct? So so this defines one to many relationship where one college can have multiple students. So it defines one to many relationship. Similarly, there will be another some use case where there will be a many to many relationships. Okay, and similarly many to one and one to one. Okay, like I mean, I think one example that Krupal gave earlier was the car and the steering wheel. So one car can have one, let's say, I mean, if we have different kinds of steering wheels as well. And I mean, so like right nowadays we have different kinds of steering wheels where some steering wheels, they can be adjusted front, back, and up and down. And similarly there are other steering wheels which with different functionalities, right? So we can define we can have a different separate class for steering wheels, and we have a separate class for cars. So one car can have one steering wheel. That basically defines a one to one relationship. Okay, I mean, does that make sense?
Yeah, yeah.
Yeah. So moving ahead, we have composition and aggregation. So composition and aggregation are two different types of association. Okay, so if we talk about aggregation, so I mean, in very common terms, we basically call aggregation as a weak association. So aggregation is basically a weak form of association. And if whenever we'll talk about aggregation, we'll say that it represents a has a relationship. Okay, like a college has a student, a college has a teacher. Okay, and it is a unidirectional association. And if we remove either of them, both of the entities, I mean both the entities that are related, that can exist that can survive individually. Okay, let's say if you remove student, the college still exists. If you remove college, the student still exists. Okay, that's why we call it as a weak form of association. There's a weak bonding over here. Okay, and how do we represent aggregation? We represent it via this arrow. If you see over here, there is this line, and we have this what do you call a square, diagonal square, we can say. And it is an empty square. It's not solid, it's an empty square. So this basically means that a student is weakly associated with college.
Mohammed, sorry to interrupt, but
Yeah.
your screen is not visible.
What is not visible?
Your screen is not visible.
No, I
I'm
can see your
sorry.
screen.
I can see it.
Okay, why? Why?
Can you just try joining again, Chirag? I mean, was that you, Chirag?
Yes, yes.
Yeah,
Let me join.
yeah, can you just try joining again?
Yeah.
We'll just wait for you. I mean, in the meanwhile that Chirag joins in again, anyone has any doubts till now? And
So
what are
what
we
what exactly do you mean by weak?
Yes,
Weak.
so
yes.
yeah, so
Yes.
weak basically means over here that if we, I mean, if for some reason we remove the student, the college entity still exists. I mean, they don't
Okay.
depend. they don't have a strong coupling. With them. I mean,
Okay.
even if you remove either of the entities, they still exist. I mean, if you remove teacher from here, the college still exists. The college entity
Yeah.
still exists. So that basically what basically defines as a weak relationship.
Okay.
It is always unidirectional.
It is always unidirectional. It is always unidirectional.
Okay.
Like I mean, like over here, if you see, a department can have students, but a student cannot have departments. Like a college, a college can have students, but a student cannot have colleges.
Okay.
Okay, in that way, it's unidirectional. Is Chirag back? Can you see the screen now, Chirag?
Yes, I can show
Okay,
this.
cool. Okay, yeah. So this is what we have around aggregation. This is what we call aggregation. And next we have composition. So composition is basically a strong form of association. Uh, where do you want? Yeah. So composition basically represents a strong form of association, and composition basically defines part of relationship. So if we talk about, I mean, again, I'll just go back to that same example that Krupal gave. So that we have a vehicle, we have a car, and we have a steering wheel. Let's say both are a different entity. A steering wheel is a different entity, and a car is a different entity. So a car is bound to have a steering wheel. I mean, otherwise, how will we drive the car? So a car is bound to have a steering wheel. If we remove the car, let's say if we remove the car, the steering wheel cannot exist on its own. So that way, over here, if you see, an engine is strongly bonded with vehicle. So an engine is a part of a vehicle. If you see, defines the part of relationship. A tire is a part of a vehicle, and the way we define, or the way we represent this is, we have, I mean, the same symbol is there, the same arrow is there. The only thing difference is that this square is a solid square. I mean, this basically represents, I mean, while we draw a UML diagram, we might come across such, we might need to identify association, or a composition, or an aggregation. So we might have to represent that in our UML diagram. So I mean, we can have one session where we can discuss about UML diagrams, or uh, whenever we are discussing any design problem particularly. I mean, at that time we can have a separate 10 minutes for how to draw, I mean, different form of conventions that we follow while drawing UML diagrams. I think that would be good. Yeah. So coming back to composition, this is what composition means. And whenever I mean, in composition, both the objects are like dependent on each other. If I remove the engine, the vehicle won't exist. If I remove the vehicle, the engine cannot exist on its own. So that's what a strong form of association means. Any doubts, anyone?
It's clear.
Okay. Yeah. So this I think this is all about each concept.
For the
Further,
composition, Mohammed, the data will flow in the both directional, right?
where?
Yeah, in the composition, that we can say data will flow in both directional.
No. So I mean, when I talk about in terms of classes and objects, I mean, this is just a diagram. If I talk about classes and objects, how we will design it is, like, let's say we have vehicle. So vehicle will be a class, and an engine will be a class.
Yes.
Okay, and when we define the vehicle class, so the engine class, I mean, we'll have. Okay, I think we are. There's some background noise. I think uh, if we can, yeah, we can just mute it. Yeah. So I'll just clear it out. So when we are defining this vehicle class, we'll have a vehicle class and we'll have an engine class. So when we define this vehicle class, I'll just write it down somewhere. I mean, it will make more sense. Let's say I write it over here only. Let's say this is unlocked. Okay. Let's say okay over here. Java, yeah. Let's say I have a vehicle class. Let me first define the engine class. You have an engine entity over here. Is this visible to everyone?
Yes.
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 So yeah, so I'll define it as float cc uh, engine capacity. Then I can have int torque, the torque of the engine, and then I can have, let's say, what else do we have? Torque. Let's say we have mileage. Okay. I mean, these are the what do we call characteristics of the engine. Let's say, I mean, this is a very simple engine. Let's consider. I haven't defined any functionality over there. Let's say we have this vehicle. Let's say we define this vehicle. So while we define a vehicle, so the characteristics of the vehicle can be int capacity. Then we can have uh, uh, string. Let's say uh, vehicle type, vehicle type, and then let's say, so every vehicle will have an engine, right? So we'll have an engine. What do you call it? Engine reference also over here. Engine type, engine specs. Let's say. Okay. So this way we had defined a strong what was that composition. This way we had composed engine with vehicle. If you see that, I mean, if I remove the engine, I mean, if I remove the engine, vehicle cannot exist. And obviously, I mean, if the vehicle isn't there, the engine cannot exist on its own, cannot work on its own. So that was, I mean, this is what the representation of what is written over here, what is drawn over here. So I mean, if you are working with composition, that engine, I mean, a reference to the engine class will be present in the vehicle. Similarly, similarly, a tire entity will also be there. Let's say, if you come back to this, a tire entity will also be there. Class tire, and the tire size can be there. Double size of the tire. Uh, String terrain type, the type of the terrain, like off-roading or city drive or all terrain, those kind of stuffs. And then we can define tire also over here. We can have a reference of tire also over here. Tire type, or we can simply write as tire. So this is how we represent composition. I mean, is that clear? Does that make sense to everyone?
Yeah.
Yep.
Yes.
Yeah. So that was what regarding composition, and I think we are still left with some part. I think we had a good discussion, but we are behind with a few things. Solid is there, and we'll just discuss solid, but I'm not sure if we have enough time or not.
We can do one thing, right? We can just brush up on the remaining topics and come for the next session, and then we can discuss if anyone has any questions on that.
Yeah, I think that would be better. I mean, if you can just go through solid principles individually. I mean, no need of going through clean code and dry. I mean, dry is like a very simple. I mean, as Krupal explained earlier as well, don't repeat yourself. So that is what dry stands for. And if you just go through every principle around solid, there are 5 principles involving. And if we have any doubts, we can have those cleared in the starting of the. We can keep 15 minutes for that in the next session.
Yep,
Sure.
sounds good.
Sure. Yeah.
Okay, and then so I mean, so what do we discuss for tomorrow? I mean, what do we discuss mainly? I mean, shall we go ahead with design patterns, or apart from discussing solid, shall we go ahead with design patterns?
What I was thinking was
Yeah,
we can definitely discuss design patterns, but let's take an example and just like discuss that pattern, right? Like for example, if you want to discuss singleton pattern, right, the simplest form, we can actually tomorrow we can have a session on like designing a logger, and because logger uses
singleton. Correct.
singleton patterns, right? So
Yeah,
so
correct.
so something like that we can just
Okay.
do like that.
Okay.
If,
Okay.
yeah.
So
Okay.
do you want to prepare something and present tomorrow?
Sure, that's fine with me. I can do that.
Okay. Okay. Cool then. Okay, then tomorrow, you can just communicate. Whatever things we have prepared, and if you want us also to go through some part, some stuffs, and you can communicate that in the group, and I'll just add all those stuffs over here. So just one thing I'll just want to show. I'm not sure if everyone has gone through it or not. So I shared this
Okay.
system design track link in the WhatsApp description also, and normally also I've shared. So all the meeting stuffs we'll have it over here. Whatever the meeting details we'll have it over here. So once Krupal shares me the topic, everything, I'll just create a link and I'll just add it over here, and I'll add the topics. Any references can be added over here, and then obviously you might have gone through these low level design and high level design uh, links. So all those things that we discussed over today, we have it over under this basics of low level design, and all the the design, everything regarding design patterns, we have it over here. And earlier I had gone through these 7 design patterns. There are 6 over here right now. One more I have to add strategy pattern, and we have the code example and everything over here. So obviously you can go through it. This is what I wanted to show, and
Okay.
yeah. So Gopal, once you share, when you communicate everything, I'll just put it across the Notion page.
Sure. Okay.
Sure then.
So we are meeting
Anything else?
to like
Yeah.
tomorrow same time, right?
Same time. Yeah. Same time.
Okay. Okay.
Okay. Okay then. And any other question? Any other suggestions? Anyone? I think we had a good discussion today.
Yeah,
So
actually, tomorrow, at which part of the patterns we will discuss, and actually we will discuss so that I can also look at some from my end so that we can suggest if or add some points also there in the discussions. So, which pattern we will discuss tomorrow actually.
Yeah. So that particular thing, Krupal will basically share with us like what all. So basically tomorrow, as Krupal was saying that we can discuss something like, we can take an example and we can discuss the topics around that. We can, let's say for example, a logger basically works with basically implements a singleton pattern. So and whatever Krupal communicates us to us by today or by tomorrow early morning, so we can just go through them, and then we can similarly we can have a session
Okay,
tomorrow.
yeah,
okay,
you just give me a couple of hours. I'll share a topic for tomorrow.
Yeah, definitely. That's fine. That's
Okay.
fine. No issue.
okay, okay.
Okay then. Okay then. We'll just wrap up for today. Thanks
Yeah.
everyone.
Yeah. Thank
Thanks
you.
Krupal. Thanks Chirag. Thanks everyone.
Thank you, everyone.
Go on.
Thank
Thank
you.
you all.
Bye.
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 Thank you. Bye.